The next set of examples, we're going to be using logarithms to solve exponential equations. Now, what's made this particular concept different than the previous one is that now the previous examples we looked at how to come up with the common base. Now this time there is no way for us to come up with the common base. So what we're going to have to do is take the common log or take the natural log on both sides. So here are the steps that's listed. Number one, this is going to be so important. We want to isolate the exponential expression. And we're going to do some examples where it's not isolated and we're going to have to convert that to where the exponential expression is by itself on one side. Then number two, take the common logarithm on both sides of the equation for base 10 and take the natural logarithms on both sides for bases other than 10. So I'm going to be asking you, do we have a base 10 or do we have other bases? And if we have other bases, we're going to have to take the natural log. When we say natural log, we're going to be using LN, okay? And when we say common log, and when there is a base 10, we're going to use common log, LOG. So it says simplify using one of the following properties. Ln of b to the x is equal to x, or x ln b, excuse me, or ln of e to the x is equal to x, or log of 10 to the x is equal to x. So we're going to be using one of the following properties. So please learn these three properties here. And the first property, the ln of b to the x, well, what you're doing here, you're going to be using the power rule, where we're going to take this exponent and we're going to write it in front of the ln. So as for this particular example, ln of b. Once we do that, then we're going to solve for the variable, meaning we're going to solve for x in that equation. So we're going to do more than enough examples in this area, so you have a lot of practice how to decide if you're going to take the common log or the natural log, and we'll discuss that in as we do some examples.